A 200-pound worker falls on a 6-foot lanyard that stretches another 3.5 feet before stopping him. The question we need to answer isn't just what's the force, it's what's the peak arresting force that the harness and anchor must handle. We'll solve it the simple algebraic way, starting with the average arresting force, then doubling it to find the peak, just like you'll need to do on the OHST exam. We start with the work energy principle. The energy of the fall equals the work done to stop it. In algebra form, weight times total fall distance equals force times deceleration distance. That's our roadmap. The worker weighs 200 pounds and falls a total of 9.5 feet, 6 free, plus 3.5 deceleration. So 200 times 9.5 equals F times 3.5. We'll solve for F next. Divide both sides by 3.5, and you get F equals 200 times 9.5 divided by 3.5 equals 543 pounds of force. That's the average arresting force, the steady pull if the lanyard stretched perfectly evenly. In reality, that force isn't steady. It spikes right before the stop. For shock-absorbing lanyards, testing shows the peak is about twice the average. So peak equals 2 times 543 equals 1,086 pounds force, roughly 1,100. Now that we've solved for the average and peak arresting forces, let's make sure the system meets OSHA limits. The 1,800-pound limit protects the worker. It's the maximum force a full-body harness can safely transfer to the body during a fall. The 5,000-pound anchor requirement protects the structure. It ensures the point holding that lanyard is strong enough to stop the fall without failing. In our example, the peak force is about 1,100 pounds, well below 1,800. And the anchor meets or exceeds 5,000, so the system is compliant and safe. Remember, solve algebraically for the average, double it for the peak, and always verify both limits before calling a setup safe. If this walkthrough helped you visualize fall arrest math, subscribe to Field to Compliance for more quick, practical OHST exam study videos.